Good evening. Welcome to the third session of Additive Manufacturing Technology. So today we'll be discussing on tool paths, area filling tool paths, and all the different types of contours, area filling methods, grid cut such as area filling path, grid cutting, pixels path, and under path we'll discuss a little bit about raster, zigzag, contour, spiral, space filling, and we'll discuss some numericals related to the previous sessions. So I just want to confirm whether it is audible to all.
Yes.
Okay. Let's start the session. So area filling methods are so there are two main steps to convert 3D model into data of additive manufacturing method. First is slicing and tool path planning. So grid cutting method there are two area filling methods. Two main steps to convert 3D model into control data of additive manufacturing machine. One is slicing and another is tool path planning. Now there are three different types of tool path. So we will gradually understand what is grid cutting method. Now there are three different types of tool path. That is, one is corresponding to the scanning of outer contour. One is scanning of inner contour, and one is scanning of inside area, which is known as area filling. This is known as area filling. Now diagrammatically if we represent it, it is, suppose this, if we consider it as outer boundary. Okay, now in this outer boundary, suppose now we have this again one inner boundary. Inner boundary, and in this area we want to add material. So, and here we don't have any material, no material. How to add material to this part? So here in this concept we require area filling method. Now so this method of adding the material in the required zone is called as area filling method. Zone is called as area filling method. Now let's take an example of laminated object manufacturing. Here, where in this case the raw materials are in form of sheets. Now, in LOM process, raw material are in form of sheets. So, now we have to remove this portion. How to remove this portion after completion? This is the part, okay, outer boundary, inner boundary. Now this region is with material. This region is with material will also be separated out. So how to remove the portion after completion of the part? Now in this case we have, now for this thing operation grid cutting is required, is performed. That means this is a combination of X and Y passes. Now this here in this case the cutting operation, like after completion of the grids, user can easily remove the grids. This will be in this grid format. User can remove these grids so that we get the outer periphery corresponding to the desired object. If we do not provide grid cutting, it will be difficult to obtain the specific part out from the object we produce. Now moving to the question which we had. Now grid cutting method includes negative of the material region in a slice. Material cutting or addition is governed by resolution of pixels. For removing the unwanted part, none above. So, this method involves dividing an image into a grid of small squares or pixels and then performing various operations on these pixels to achieve desired changes in the image. So, negative of the material region in a slice, this means this does not accurately describe the grid cutting method. The negative, it is not commonly used in the context of image manipulation through grid cutting. Now, material cutting or addition is governed by resolution of pixels. This is the correct explanation, one of the correct explanation. Here, the grid cutting image content with each grid cell or pixel can be manipulated, added or removed based on the resolution of the image, meaning that changes are made on a pixel by pixel basis. Now, for removing the unwanted part, yes, grid cutting method also removes the unwanted parts of an image, but this is not completely. These both are the correct options. It involves more than just removing unwanted part. It also involves pixel level manipulation. So these are the correct options. So in this case we have the completion of grids. User can easily remove the grids later on. Now if we also Okay, so next question. Okay, now here this question is little it's not like we'll discuss what is exactly area filling path. So the area filling path, these are, one of them is grid cutting. What are the methods involved in area filling? So we will discuss all these. So area filling paths are grid cutting, pixel, path, and mask. Now grid cutting, which we just saw, it is for removing the unwanted part. Pixels is material cutting or addition is governed by resolution of pixels. Now path includes the different types of path to be followed, like raster, zigzag, contour, spiral, hybrid, continuous, and space filling. I'll write it here. Space filling also. Hybrid, continuous. So these are all belong to path. Now we will discuss like what are in the, like in our CAD. So these are all the, is my screen visible? Just wanted to confirm. Okay. So these are the various area filling parts. Now we'll discuss what are the about the different area filling tool paths in the following question. So now area filling tool paths in the context of computer design or CAD or CAM, area filling tool paths are used to fill regions of a shape with materials or patterns. The different parts have different distinct advantages depending on specific requirement of the manufacturing process and the desired outcome. Now, raster, zigzag, contour, and zigzag and contour path. Now, out of these four area filling tool paths, which of the following method is most advantageous? So first we'll understand about all these methods. Now, raster is Raster is simple, efficient, and robust with any boundary. Now we have different types of raster. X raster, X raster, Y raster, and XY raster. Now X raster. Suppose this is your tool path. Now this is your object. The tool will, in X raster, it will move from in the X direction, from this side to this side. So this let us consider this as, and here stresses will be in along sigma 1 and sigma 2. Now suppose let's consider object moves from 1 to 2, and then again from here it will move, this is the dotted line, 3 2 to 3, then this, in this way it will come to 4. Now this 3 2 to 3 will be in air. Okay, it will be the retraction. Now for Y raster, the tool will travel from 1 2, then it will come from in air, this is 3, it will reach 3, then it will again travel to 4. Similarly this will be done. Now XY raster means this will be along both X and Y direction. This is XY. Now dotted lines are movement of the tool in air. So XY raster, this is done to get the homogeneity in the deposited material property. XY raster, this is done to get the homogeneity in the deposited material property. Now this is about the raster path. Next is the zigzag tool path. Now in the zigzag tool path, or this is also known as direction parallel tool path, this is the most commonly used tool path in additive manufacturing because it is less build time and fewer transition motions. Now here what happens is, let's say this is our object which is model. Now the tool is here, it goes here, then it travels along this, the darkened portion. I am just circling it. Then it again comes to this position. It travels along this. When it moves, then it again travels along this and it comes back here. So what happens is in the ends, these are the ends, tool does not lift. It moves along this path. It keeps on adding material and reaches to the it keeps on adding material and reaches to the left next line. So boundaries of the contour are approximated by linear edge. However, due to the discretization errors, like here, some discretization errors may occur, which is not parallel to the tool motion, and that is why the outline is sometimes poor. So this leads to poor surface quality of the printed part. But this has less build time and fewer transition motions. Less build time, fewer transition motions. Now in these ends, tool does not lift. It keeps on adding material and reaches to the next line. Now because of this, now this is very important. Now boundaries of the contour in this zigzag path are approximated by linear edge. However, due to the discretization errors, on any edge which is parallel to the tool motion discretion, the outline is poor and leads to poor surface quality of the printed part. Now we understood what is the raster path, zigzag path. Now next we'll move on to contour path. In contour path, also known as contour parallel model offset, here this is applied by offsetting the contour of the geometry, like a series of offsets starting at the outer boundary and this progresses towards the center. Now creates a series of offsets starting at the outer boundary and progressing towards the center. Now next is what is zigzag plus contour path. Now this is a combination of different approaches for benefits. Like here we fill few lines from outer by contour path parallel, and from inside we use zigzag. Now contour parallel from inside, why we don't use here? Next is zigzag plus contour path. This is the most advantageous part. Combination of different approaches for benefits, printing benefits. Okay, so here we fill few lines from outer by contour path parallel, and from inside we use zigzag. So why we don't use the contour parallel inside? Because this will leave cavities. Cavities means this will leave some voids or surface which will create surface defects. Contour parallel from inside will leave cavities or voids. So but this is zigzag, and combination of zigzag and contour path is the most advantageous out of all the methods. Okay, next we'll solve a numerical. So here in this question we have been given the ASCII format of STL file, which is the vertex of the three triangles. Now it is written that if a triangle is translated plus 3 unit along x-axis, then plus 3 unit along y-axis, and then plus 3 unit along z-axis, what will be the unit vector corresponding to the new facet normal? So many people had doubts regarding this question last class. So that is why I have taken again this question and we'll solve it. Now we will take this vertices and start solving the question. Now, according to the question, we have the triangle whose vertices are P1, P2, P3. We will name it as, this is 1, 1, 1, 0. This is 1, 2, 1. This is -2, 2, -1. Okay, I'll just show you the question again. 1, 1, 0, 1, 2, 1, -2, 2, -1. Now, it is asked that we are rotating along x-axis 3 unit, along y-axis 3 unit, and along z-axis 3 unit. Now, what will be the unit vector corresponding to the new facet norm? Now, we have a rule that in translation, normal will not change with when it is rotated with respect to any axis. Maybe let it be z-axis or y-axis or z-axis. So, we need to completely ignore this part. We need not consider from here to here. We do not need to worry about this. Okay, so we will solve the question now. Let's consider this as v vector, this consider this as w vector. Okay, now v is equal to p2 minus p1, and this will be 0 I cap plus j cap plus k cap. W will be P3 minus P1, this will be minus 3 I cap plus j cap minus k cap. Now we need to calculate the two vectors and take the cross product. Okay, calculate the two vectors and take the cross product. Now how we will find the cross product? This is I cap, j cap, k cap, 0 1 1 0 1 1 3 minus 3 1 minus 1. So 0 1 1, this is 0, minus 3 1 minus 1. Now we will multiply. This will become I cap 1 minus 1 minus 1 minus 1 to minus 1. Now minus j I cap minus 1 minus 1 minus j plus 3 plus k 0 plus 3. This will become minus 2 I cap minus 3 j cap plus 3 k cap. Now we will take out the coefficient of normal vector. Coefficient of unit normal vector. This will be minus 2 I cap minus 3 j cap plus 3 k cap by root over of 2 square plus minus 3 square plus 3 square. Now this will become minus 2 by 2, 22, 4, 9, 13, plus 9, 20. Minus 2 by root 22 I minus 3j by root 22, and this will be plus 3k by root 22. Okay, now upon solving this we will get minus 4.42, this will be 0.63, and this will be plus 0.63. Now according to the option, minus 0.42, 0.6 minus 63, option 2 is the correct answer. So in this way, if it is given the unit rotation of by some units, you need to take into account this part, that if in translation normal will not change in x or y or z axis, and here it is asking what is the unit vector corresponding to the new facet normal. Okay, so the next question. Now here, a sphere has to be built by an additive manufacturing process in which the triangles of the STL file with facet normal are at an angle more than 45 degree from the build direction require a support structure. Now select the correct option. More than 2/3 surface area of the object will require support, less than 1/4 surface area of the object will require support, less than 1/8, or more than 5/6. Now we will understand the question and solve it. First we will draw a sphere. Okay, now here it is, consider this is the build direction. Okay, so let us consider the sphere and the build direction is this. Now we know as per the rule that when more than 45 degree is we have the angle, support is required. So now we will divide the sphere into, first we will divide it into 4 parts, and I'll explain where all supports are required. Now divide the circle, step 1, divide the circle into 4 parts. Now this is considered 90 degree, this is 45 degree. -45 degree, 90 degree and 0 degree. Now here along this part, the build direction is at 0 degree with normal. Build direction is, this is the build direction, this is the normal. Okay, now here it is at 90 degree. We need support. Same again here, we don't need support. Here we need support. Now at this 0 degree we don't need support. When it is more than 45 degree, like here in the condition, we need support. So in here when it is 90 degree, we need support. Now we'll again divide the sphere into more parts. Consider this the sphere. Earlier we divided into 4 parts. Now we'll again divide into 8 parts. Okay. Now here this is 90 degree, 0 degree, 45 degree, 45 degree, 0 degree, 45 degree, 90 degree, 45 degree. Now after dividing into more parts, we see that this from here, if we consider 0 degree, this is 45 degree, this is more than 45 degree. So this part will need support. Now here it is theta is greater than 45 degree, this part will also need support. Here theta is less than 45 degree, here theta is less than 45 degree, here theta is greater than 45 degree, we will need support. Here theta is greater than 45 degree, we will need support. Okay, so according to this, if we see now answer now according to the question, what is the question? That less than 1 by 4 surface area of the object will require support. Now here it appears that half of the object requires support, but that is not correct. Now in our lecture, as explained by sir, we know that in the manipulation of STL file, when the facet normal is upward, that does not require support. Slide 7, it is mentioned by a professor in manipulation of STL file that when facet normal is upward, we do not require support. Now in all these in this condition, the facet normal is upward, so we do not require support. So answer is not half, it is 1/4 answer. 1/4 of the object requires support. Not half. So the correct option is less than 1/4 surface area of the object will require support. I hope this is clear. Let's move on to the next question. So here in the question we have been given 3 triangles which require the support structure in STL file. Assume the bell direction is plus z and the base is at z is equal to 0. Find out the volume of the support. Now we'll first understand where this is triangle number 1. Now this is triangle number 2 and this is triangle number 3. Okay, now here we need consider this that we need support. Okay, now we need to find out the volume of the support required. So let's calculate. Now I'll just write the vertices of each triangle first. Triangle 1, the vertices are 20, 0, 12, 18, 12, 15 and 15, 3, 15. Okay. Triangle 2, it is 18, 12, 15, 15, 3, 15 and 8, 10, 12. Triangle 3, I'll move on to the next page. Triangle 3, it will be 15, 3, 15, 3, 15, 10, 0, 10 and 8, 10, 12. 15, 3, 1, 5, 8, 10, 12, 10, 0, 10. Now the method is that we need to calculate the area of each triangle and So after calculating the area, we need to find the volume. Volume is area into average height. Now we'll do the first triangle serially. So area of triangle 1, area of triangle is equal to half x1 y2 minus y3 plus x2 y3 minus y1 plus x3 y1 minus y2. Now triangle 1, 20, 0, 12, 18, 12, 15, 15, 3, 15. So that will be half into 20, 12 minus 3 plus 18, 3 minus 0 plus 15, 0 minus 12. Now this by calculating it will be 27. Now volume is equal to area into average height. Now average height is average of z coordinates. Now in case of triangle 1, the z coordinates are 12, 5 and 5. 12, 15 and 15. This will be 12 plus 15 plus 15 by 3 is equal to 14. Now volume of triangle 1 is equal to area, which we just got, 27, into average height is 1414. This will be 378. Similarly for triangle 2, which had the vertices 18, 12, 15, 15, 3, 15 and 8, 10, 12. Triangle area is half, 18 into, I'll just do it, 18 into 7 plus 8 into minus 9 plus 15 into 2. This is with respect to this formula, half into x1 y2 minus y3. So here x1 y2 minus y3. Okay. Now this will become 28. The average height will be z coordinates, which will be 15, 15 and 12. Okay, I'm sorry, this is average height is 15, 15 and 12. So it is 14. Now volume of the triangle is equal to area into average height is 42 into 14 is equal to 588. Now similarly for the triangle 3, we have the coordinates 15, 3, 15, 8, 10, 12, 10, 0, 10. Now area is half x1, again this formula x1 y2 minus y3. So this will be x1 area of triangle 1. will be 15 minus 10 plus 10 into 7 plus 8 into 3. This will be 28. Now average height will be z coordinates average 15 plus 12 plus 10 by 3 is equal to 37 by 3 is equal to 11. Now volume is equal to, volume of the third triangle will be A3 into H3. This will be 28 into 11 is equal to 308. Now total volume is equal to V1 plus V2 plus V3. Now when we are solving this, is 378 plus 588 plus 308. This will be 1274, which we, according to the options given, 1311 is the closest. So the correct option will be 1311. But when solving, we are getting 1274. 1311 is exactly, we are not getting that value. So according to the question, this is the correct answer. So now the next question. Now here we have been shown an object in which we have to find out the containment method of support generation from contours. Now that means that we have to find the support plus object first. Then from that we can find out the supports. Now first is, if we consider this area total, now when we consider this area, consider this as a cube. Okay. Now this object consists of 4 truncated cones. This total, if we consider this one, is 150. This is 60, as it is given here 60, and the width, depth will also be 60. Okay. Now when we consider this entire thing, this will be as your support plus object. Now this is saying that we need to consider the containment method of support generation from contours. That means what is the total support for the entire thing. Now why we are not considering this area? This is because there is a rule that if facet normal is upward, we do not need support. If facet normal is upward, we do not need support. So in this case, we are not taking the support. Now first we will First we will calculate the volume of the truncated cones. Now for that area, for this region, we are considering it as a cube. This will have the dimensions of 60, 60 and 150. Now the volume is 150 into 60 into 60. This is 540,000. Now this is entire support plus object. Now we need to find out only the volume of the object. After that we will get this volume of support of material by subtracting. Next is volume of truncated cone. Now this is the truncated cone. Okay. Volume of truncated cone is equal to half 1 by 3 into pi into h r square plus small r square plus r into r. Now this will be, since we are considering 3 cones, that is why we will take it 3 into this total. Now this will be 3 into 1 by 3 into 3.14 into, now height is, the entire height is, each cone has a height of 50. So we will write 50. Now bigger radius is 60, that will be 30. Diameter is 60, so radius will be 30, and smaller diameter is 20, the radius will be 10. Into 50, 30 square plus 10 square plus 30 into 10. Now this will be 204,100. This is the volume of object. Now volume of support material will be, continuing this itself, volume of support material is equal to minus, earlier we got here 54000 minus 204,100. This will be approximately 335900. Now in your options it is approximate to option 2. Answer. Okay, so these were the questions. Any doubts so far? These were the portions to be discussed today. Yeah, yes.
Last week and this week.
Okay, yeah. This will I'll be uploading by tomorrow. There were some, actually there were some disturbances, so I could not upload. So actually the entire notes you can access from Drive for the last week, and today's also I'll upload. Yeah. Yes. Yeah. It will be there. It will be there. Yes. It will be there. Everything will be there. Yeah. Yeah. Okay. Anything else? Any other questions or doubts? No, that NPTEL doesn't provide previous year question paper. Mostly the questions which you will be getting in final exam will be similar to your assignment questions. No, that depends. Some portions are objective, some are subjective. Yeah. So this numericals will be there. That will be subjective itself. Yes, calculator is allowed. Any other questions or doubts or any other clarifications? Okay, so if there are no further doubts, we'll end the session. Let's meet next week again. Okay, thank you all for attending the session. Oh,
हेलो आमा ओके ओके हाँ 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 हॉलिडे ओके ओके टुडे व्हाट हैपेंड अम्मा टुडे रेन टुडे रेन ओके ओके टुमारो 12 टुडे नॉट कमिंग ना ओके ओके हाँ हाँ ओके अच्छा ओके हाँ ओके हाँ कंफर्म नो लेट ओके 12:30 होम होम टुडे मॉर्निंग हॉलिडे